Hello, everyone. I want to start with sharing one of my biggest frustrations with you. But I would like to introduce that by asking two questions. So I would like to see some hands for that. Who of you does regular code reviews? Good, a lot. Who of you has ever pointed out common coding guidelines during these reviews? Good, because this is directly related to my frustration. Because when a colleague of mine opens a pull request and I start reviewing the code, I find myself repeatedly pointing out the same things over and over again. This can be anything from the common coding guidelines, other code style issues, or subtle bugs. It's okay if I have to point that out in a code review, but the fact that I need to do this repeatedly, that is what annoys me. Because if it's the fourth time that week that I'm pointing out the same thing, I start to wonder, can't we actually automate this instead of me having to manually do this? Well, my name is Rick Ossendrijver, and today I'm going to show you how we can actually start automating away this problem. So the title of the talk is Say Goodbye to Bugs and Anti-Patterns with Error-Prone, and Error-Prone is the tool that we're going to use for this. I'm a software engineer in the Java platform team at Picnic, and Picnic is an online supermarket based in the Netherlands. And we are active in 3 different countries, namely the Netherlands, France, and Germany. So, the agenda of today. I will give a bit more context about Picnic, and especially about the processes that we have resolving around code quality. And then my favorite part, where I get to introduce Error-Prone. Then I will show you how you can actually start using Error-Prone in your code base or in your company. And last, I will give some lessons learned about our journey with Error-Prone from within Picnic. Our customers can go to our app, they can order their groceries, we have a lot of products, and they schedule a time for when our electric vehicles will do the actual delivery. So our customers only see the app and the person that does the actual delivery with the electric vehicles, of which you see a cartoonist version on the right. But of course, you can imagine that to empower this whole system, we have a lot of software. Because we have the supply chain, we have a lot of warehouses that all run our software, we do the routing algorithms, and everything that's used by, that we have for backend services that the customer interacts with via the front end. But we still want to heavily extend. We want to become the online supermarket of Europe, so we need to write a lot of more software to extend to other countries. And we believe that having an excellent code quality is really important in order to be able to adapt quickly and be flexible. So we are striving for this excellent code quality. But when I hear code quality, I always think about this image, where the amount of WTFs per minute gives a clear indication of how good the code is that is being reviewed. But kidding aside, what do I mean with an excellent code quality? So yeah, of course you need to have a good architecture that's really extensible and flexible. You need to adapt quickly while maintaining the current stability for your customers. And we really believe that having a thorough review process helps with this. So we focus on, so we're really strict with the things that we do allow in our code base, and when something can definitely be improved, we're really focusing on that. And we have a lot of multiple people reviewing every pull request. And one of the other things that we focus on is having the least amount of possible bugs in our code, and we also really want a uniform and consistent code base. So, because we still want to heavily expand, we will do a lot of reviews. And in order to be quick with that, we really believe that the automation can play a key role in this. And one of the focus points is that we want to limit the amount of bike shedding that is happening during these pull requests. Well, what is bike shedding? Well, it's also known as the Parkinson's law of triviality. We don't want to waste our time discussing trivial things. We should focus on the things that are way more important. So there is this example where they are discussing only a few minutes about a nuclear plant which costs millions, whereas more people know things about have an opinion about the bike shed they are building, which costs only $1,000, and they discuss about it, about the color and whatnot. So we are focusing on limiting the amount of bike shedding, but what do I mean with respect to code? Well, let me give you an example. So let's say someone writes code and another developer comes in, reviews it, and sees that someone changed something from method A to method B, while both methods are doing exactly the same thing. In this case, it's about the string.isEmpty to the string.equals with an empty string. And another colleague comes in and says, hey, I thought we agreed on using method A instead of using method B. And what you can see is that there are some upvotes on this comment, so this can easily trigger a whole new discussion in this pull request. Having a discussion once is fine, you can of course do that, but you should not repeat these discussions. You should settle on something, and you should make sure that this is enforced over your whole code base, such that the discussion cannot happen again. Of course, this is a fairly simple example, but you can do this with any kind of change. Even imagine when someone else joins the team, you have these guidelines, and someone else joins and says, yeah, but I do not agree with these guidelines, and you start discussing them, these rules again, because they are not enforced. And that is exactly the problem. So within Picnic, we use a few tools that help limiting the amount of bike shedding that we do. And one of the easiest examples is the use of a formatter. So we use the Google Java format. It's a fairly opinionated formatter, so there's simply no discussions possible about where to put the curly bracket, either on the new line or the same line as a class definition. Another type of tools is the static analysis tools. So take, for example, SonarCloud, CheckStyle, and Spotbugs. Those are the industry-proven best practices. We use them internally as well. But the thing is, they have a limitation. Let's take, for example, SonarCloud. If you open your SonarCloud dashboard, it almost directly screams at you, hey, you have over 40 days of technical debt. You should fix this immediately. Well, you're like, yeah, I'm working on this high priority feature that the business wanted done yesterday. So in practice, no one really touches this technical debt. And the fact that these tools flag all these, let me rephrase, the fact that these tools cannot automatically fix your code is the limitation. So we want to go one step further. And that brings me to error-prone. So error-prone is an open source tool created by Google. It's a static analysis tool for Java that can find and detect bugs in your code, but it can also provide a suggested fix for you. And if you run error-prone in patch mode, it can automatically apply that suggested fix for you in the actual source file. So it can automatically fix your code. Well, how does that work? Error-prone is a compiler plugin. What does that mean? Let's say you have a Java class. The compiler starts compiling your code, and during this compilation, a lot of extra checking, validation is done. So a lot of extra context about your program is gathered. And right after the compilation is done, error-prone hooks in and can use this additional context to do a much more thorough analysis. And once error-prone found the violation, it still has a link to the actual source code. Hence, it can provide a suggested fix for you. And then again, if you run it in patch mode, it knows exactly where to apply that fix. So if you enable a specific bug pattern in your code, an error-prone check, it will go over your whole code base, find all the violations, and fix them all in one go. And that's what makes error-prone really powerful. So out of the box, there are over 500 error-prone checks provided by Google. They are categorized in 3 severities: error, warning, and suggestions. And you can configure them just how you want them to be configured. Yeah, you can disable specific checks if they don't work for your code base, for example, if you're using a specific library, for example. But the thing is, if you want to write a check on your own, it's quite complex, because for those of you who know, you have to work with the abstract syntax tree, and that can be quite complex. But The people at Google thought about this, and they wanted to provide an easier way to specify refactorings. So what they did, they created another tool on top of error-prone, and that tool is called refaster. So refaster is a tool with which you can specify these refactorings using before and after templates. Let me show you an example. So at the top we have a before template, and what we can say is that we want to match any arbitrary string expression where the equals is used. And if we apply the refaster rule, then we want to rewrite that to the .isEmpty. So on the left we have an example of something that we would match in the code, and if we apply this refaster rule, then it would automatically get rewritten to the .isEmpty. As you can see, it's a fairly easy way of specifying a refactoring. And of course, this is a simple example, but you can do this with a lot of things. The only downside to refaster is that it only works on expressions and statements, which generally means things inside method bodies. So now that you know about error-prone and refaster, I actually want to show them in action. We're going to look at a Maven project, but this Maven project, but error-prone also works for other build systems like Bazel and Gradle. The link will also be on the final slide. But before we dive into the demo, I need to tell a little bit about the build, such that you understand what we're going to see. So we have our normal Maven build, and we're going to add 2 profiles on top. And the first profile is the error-prone profile. So what this says, the ID is error-prone, and what we want to do is we want to add some additional configuration, and in this case to the Maven compiler plugin. So we have the Maven compiler plugin, and then we want to add some arguments by saying, hey, -x plugin error-prone, we enable error-prone, and then we can configure error-prone just like how we want it. And I put here a simple example that shows you how you can disable a specific bug pattern. Well, we don't target JDK 8, so you can just say that you want to disable it. And the other profile is also on top of the error-prone profile, and that is the patch profile. So then we say, hey, run the error-prone checks that we want to run, but run them in patch mode, which will automatically, this is here we specify the patch location, and because we say in place, it will know that it should actually update your source file. And we have here the patch checks, which we will use later on. Here we can say, hey, we want to run this specific error-prone check in patch mode, or if you don't specify anything, it will default to the empty string, which means that it will run all the error-prone checks. Okay, let's go to the demo. So what you see here is a fairly simple class, and I'm going to ask you something. So in every method, there is something that can be improved, or that is probably wrong. So I want to ask you for some input if you spot anything that's probably incorrect. Anyone? I see some pointing fingers. Otherwise, we're going to ask error-prone to take a look. Yeah? Okay. Well, I have the command ready, so that's good. We start with a Maven clean package, so a normal build, and then we do the -p error-prone to enable the error-prone profile. I'm going to run it, and we are going to look at the results. And indeed, error-prone found something. So it says, hey, on line 21, which is this one, it says, hey, there's a refaster rule match. Did you mean return string.isEmpty? Well, yeah, that's a good improvement. And the other one is on line 10, where it says, hey, there is a dead exception. Here we are creating an exception, but we're not actually throwing the exception. So basically, we're doing nothing. And the other one is on line 17, where we have an immutable set. And we are doing an identity conversion because we're doing a copy of, which doesn't really make sense. So, well, clear, good examples. But now we want to have the patch magic, of course, because we don't want to manually fix this. So we pass -p patch to enable the patch profile. And when I click here, we indeed see that it is now updated. So we have the throw, and we do not do an immutable set copy of, and we have the string.isEmpty. Well, now you might wonder, what if this copy all for a very specific reason is an edge case that you don't want to update? Well, what can you do? Well, you can add a suppress warnings for this check. And if we now run the command again, we will see something. Because besides the fact, OK, there it already is. It was too fast. So here was another optimization of a refaster rule. But the point is, this copy off is now still here because we add the suppress warning for a specific case. OK, so those were some fairly trivial examples. Let me give you some more examples of what error-prone can do. So, of course, there is a documentation website where you can find information on all the out-of-the-box provided error-prone checks. Let's go over a few. So there's the incomparable bug pattern that goes over your sorted collections and tries to identify when you're using types that are not actually implementing comparable, because that's likely a bug. Another one is the check return value. This is a mechanism that allows you to specify when the return value of a non-void method has to be checked. There are already some big libraries that use this, and you can also use it in your own code to make sure that when it's really important to use the return value, that it is actually checked. A good example is the string.concat. If you're not actually catching the result in the variable, it's basically a no-op. There's also the equivalent, like the can ignore return value variant, which does it the other way around, saying, hey, you don't need to check this. Another one is the constant field. So if you have a field that uses the constant case naming, it probably has to be a static and final field. So yeah, error-prone will flag this. Maybe there's a checkstyle fan that says, hey, checkstyle can also automatically identify this. Well, that is true, but error-prone can also automatically fix it for you. So, and this is one that's a bit more powerful. So I imagine that in almost every team, there is someone who's really a fan of immutability and really wants the other developers to know and make sure that everyone adds the final keyword everywhere where it is possible and is really pushing for that. Because by default, let me rephrase, the default would be that a variable is mutable while he's a fan of immutability, so he wants you to add the final keyword. But if you do that throughout your whole code base, your code base can get quite cluttered. So what you can do with the var bug pattern, you can actually completely flip the default here. So instead of having everything mutable, a local variable is by default immutable. And if it's not, so if it's mutable, then you have to add the @var annotation, which is this is an example. So you don't need to add the final keyword because it's now the default, the immutable variant. And if you want to show that you're actually doing something with a variable, then you add the @var annotation. So this bug pattern helps you with flipping the default here completely. And error-prone will make sure that you cannot miss any occurrences, because if you have a local variable that you're changing, error-prone will say, hey, you need to add the @var keyword here. Another thing with which error-prone can help is migrating usages of APIs. So, for example, when the optional got introduced, it had the get. And everyone started using that, but at some point there was the or else throw, which is actually the preferred way of using the optional. But if you would have to rewrite all the occurrences that you had in your code base, then it would cost quite some time, and it's really easy to miss some occurrences because it's done manually. So instead of doing all these things manually, you can just run this refaster rule over your code base, and instead of having the default optional.get, you now switch to the or else throw. Again, this is of course a fairly simple example, but you can do this with every API that you want to. So now that you've seen what error-prone is, I want to actually switch to how you can start introducing it in your team or your company's code base. And this process is quite hard because you cannot start with enabling error-prone and enable all the 500 bug patterns in one go and say, hey, I created a pull request with a lot of changes. Can you please review and merge this? Because that's never going to work because you have so many changes. So we have to take a specific approach here which will help us with that. So there are 3 levels. You start with creating a baseline. You have your project and you add the 2 Maven profiles that we talked about. And you configure error-prone in such a way that all checks are disabled. Because of these 2 profiles, you can actually run specific checks on your code base to show other developers from your team or company how cool the changes are and how nice they are for them. So you disabled everything and you pick an error-prone rule of which you think, hey, the team will definitely like this because it fixes a really important bug that you maybe encountered before, or it's a good cleanup of your code base. So you run this specific check on a branch, you create the PR, and you ask for input of the other developers. And you get that merged. But then you have to repeat this process quite a few times because you need to get them into the habit of reviewing these PRs. Because again, if we would enable multiple checks in one go, the changes are way harder to review. But we will see this later on. And once you repeated this process a few times, you will get to the level where you can enable all default error checks. This sounds nice, but let me show you how this step is done. So I went on GitHub, I looked for a nice open source repository, and I found a good one. This repository was definitely in need of some error-prone. They didn't use a formatter, there were a lot of unused imports. So what I did, I brought it up to a baseline, I checked it out, added the formatter, ran the formatter, added the 2 Maven profiles, and from there we can look at the steps. So, here you see one of the 2 profiles, and in the bottom I have the command ready. So we have the Maven clean package again, we have the -p error-prone, the -p patch, and here are the patch checks that we talked about earlier. Because now I can specify the unnecessary final as a specific check that I want to run over this code base. So to show you that, I should now actually press enter, but if I would do so, we would have to wait for a few minutes because it's a code base with over 200,000 lines of code, so that's a bit too much. So instead of pressing enter, I will actually cherry pick a commit I made beforehand. Okay, so it is the commit is applied, and what we can see is that almost 800 files are changed, and we have over 4,000 changes. Let me try to push this and see if that works. And yes, it does. Then we're going to inspect the actual changes. And the idea here is that because we enabled one bug pattern, the changes are fairly trivial to review. Because, oh wait, let me increase the font size a bit. So if we scroll through the PR, we see that the changes are trivial and they are all very similar. So because our brain is just pattern matching the changes, it's easy to review this when there are like a lot of changes to review. And at some point when we review the changes, we can just simply say, create a pull request, and we can ask other colleagues to do the same as well. And then we need to repeat this process quite a few times to enable all the bug patterns. Just to briefly repeat, we started at the baseline and we went from level 1 to level 2. So, error-prone at Picnic. Within Picnic, we have quite a few Java repositories. We have over 50 to 60 Java repositories, and all repositories have one common parent. And in that parent, we have a lot of common configuration. We have some core modules. We manage a lot of dependencies. And we also have the error-prone configuration there. And what we also provide is a patch script. So in every repository, a developer can easily run the patch script, and that runs a normal build with the two profiles enabled. So if you wrote some code and you have a violation of an error-prone rule, the patch script will automatically apply that, and you will have a git diff, basically, so you can inspect the changes and see what violation you had. And this is important because we set up our CI in a really convenient way that once a developer writes code, creates a pull request, our CI is doing a lot of checks, and if the developer forgot to run the patch script, it will, a tool called Danger will give an error on the pull request saying, hey, there is a violation, please check out the code again and run the patch script. Because we don't want to automatically commit these changes, because we need to make sure that the developer stays in control of the changes that we are introducing. But the nice benefit of this setup is that if you enable a specific bug pattern and you applied it over your code base, you can be 100% sure that this bug will never occur in your code base again. Because the patch script, if there are changes, it will not allow you to merge the changes. I think by now it's quite clear that we at Picnic are quite a big fans of error-prone. So I want to take it one step further. A few years ago, we started with creating our own internal repository, where we created a lot of new rules, where we went further with consistency and guiding API usages. And we also made some extensions of error-prone. And at some point, we were like, hey, the things that we have here are actually quite valuable, and we think we should actually share them with the rest of the community. So about half a year ago, we actually open sourced that repository, and the name of the repository is error-prone support. And on the right, you see our mascot. Everyone, meet Cody, the code buster. He's there to clean up your code and remove all the bugs. So error-prone support contains about 750 refoster rules and over 40 error-prone checks. And yeah, they are all focused. Well, let me show you an example of that. So there are multiple ways of checking whether something is null. And instead of having 3 different ways, we say, okay, we want in our code base only one way of checking whether something is null or not. And we have a lot of these rules that are really focused on the consistency of our code base. And another strong one for guiding API usages is the Flux flat map usage. So we use a lot of reactive programming within Picnic. And you don't need to know about the details, but here it's about the Flux flat map where you pass one function as a parameter. Because if you use that, or the flat map sequential, with only one parameter, then what happens is that implicitly concurrency is set for you. And what we encountered is that quite a few times there were some bugs that we couldn't really figure out what is actually happening. And because of this implicit concurrency, we were in the dark about what was actually happening. So what we said, okay, instead of this flat map, what you probably want to use is a concap map. So we by default rewrite the usage to a concap map. But if you really want to have a concurrency, that is fine, but then you need to specifically specify a concurrency. And in that way, we don't get unexpected bugs like that. And another one is the collector mutability. So for the collectors .toList, toMap, and toSet, the Java doc actually states you cannot make any assumptions about the immutability. And well, we're fans of immutability, so we prefer to rewrite everything to the immutable variant. So what we say, instead of the collectors.toList, you probably want to use the toImmutable list. But if you know what you're doing, or you have a specific case where you really need a mutable list, then you have to use the toCollection collector instead of the collectors.toList. So both are okay, but we rewrite it such that the preference is really to the toImmutable list. And besides all these rules, we made some extensions. So if you use the original error-prone, it's relatively hard to run refaster rules. We made it in such a way that you can run a lot of them at the same time. And as you might imagine, if you're writing 750 refaster rules, you also need to make sure that they're actually rewriting code as you expect them to do. So we created a test support module that allows us to easily verify via input and output that they're actually rewriting correctly. And during the demo, we saw that the refaster rule also showed something in the terminal. It flagged a violation. Well, that is not officially supported by error-prone. That's a feature of error-prone support. And we also have a documentation website. So this is the homepage, which is the README of the repository. But the cool thing is that if one of our error-prone checks finds a violation in your code base, it will show a link to our documentation website where you can find some additional information about it. So for example, we have a direct return check, and what we do is you click on the link, you go to here, you see some explanation on why we have this check, what code it will flag, and how you can of course suppress that specific occurrence if it's a false positive. But we also have this for refaster rules. And let me show you an example that clearly demonstrates how much we value consistency. And that is this one, where we rewrite a lot of variants that are actually almost checking exactly the same, namely whether a collection is empty or not. So we rewrite quite a few variants to one and the same thing. So when we started with error-prone support, all these rules were not enabled by default in our build. But at some point, we had so many rules that we actually had to start applying them. But yeah, we again had such a huge amount of checks that enabling them all at once would mean way too many changes to actually properly review. And we also needed to check whether the developers actually liked all the rules that we introduced, whether they were correct or there were some edge cases that we had to account for. So we had some validation to do. So we thought about an approach, and what we actually did, we started creating a lot of pull requests in the repositories from other teams. So in total, we created over 60 pull requests, and we asked all the developers for feedback and their honest opinion on the checks. And here you see some numbers of the sizes of the pull requests that we had. And in total, we rewrote over 33,000 lines of code. And as you can imagine, based on these numbers, this boosted my GitHub stats quite a bit. So how did such a pull request look like? Well, again, we couldn't enable them all at once, so we split them into different categories, into different topics. So if someone started reviewing the pull request, they had to go over all the commits and see the changes based on that topic. So it was a lot easier for them to see if they were actually correct or they actually liked how the code would be rewritten for them. And of course, we had quite some opinionated developers, which is a really good thing. We had a lot of good discussions about the rules. But at some point, when we got feedback from multiple people from different teams, we thought, okay, maybe this rule is not the best, but let's see what all the developers within Picnic think about this. So we started actually creating polls on Slack. And we noted some advantages, disadvantages, and then we said we actually called for a vote and said, okay, do you like, in this case it's about the local time, in which has 3 ways of specifying one and the same thing. We say, hey, we want to get it consistent. Which one do you prefer, or should we not rewrite this at all? Well, and because we used this mechanism, the developers were really happy because they were able to vote on these matters before we just enforce them over the code base. And because they were really a part of it, they actually liked it a lot. Because there were also developers that said, I don't matter if it's option 1, 2, or 3, as long as it is enforced and consistent, and I don't need to think about it anymore. So I'm happy to say that by now we enabled all these rules on all Picnic's Java code. But I want to quickly get back to the beginning, because I said that the goal was really to automate parts of the review process. So if a developer was thinking, hey, I already made a comment about this week, why do I have to write this again? Let's create a refoster rule for this, for example. That is what we wanted to achieve. So when we had this system, we had to we had to incentivize other developers to actually contribute their ideas to error-prone support. So we thought about this on how we could incentivize the developers to actually do this. So we used a really powerful mechanism for this. We created custom-made stickers of our mascot. And we said, hey, if you make a contribution, then you get a sticker for this. It sounds silly, but it worked quite well, because within a few months' time, we had over 30 contributions from within Picnic. I also have some custom-made stickers at the end here, so don't forget that. It's mainly a reminder for myself. And yeah, as for the external adoption, we are also doing quite well. So Checkstyle and an open source repository from Uber also ran our checks. And a popular caching framework, Caffeine from Ben Maines, also uses error-prone support. So I've talked a lot. Let me show you how simple it actually is to create a refoster rule, to get some hands-on experience with error-prone support. So we are going to write a fairly simple thing, namely the string.copyValueOf to new string. And let me show you why. So this operator actually calls new string itself. So, well, just as an example, for example purposes, we are going to do this. So instead of copyValueOf, we actually want to directly call new string because we have a lot of violations in our code base. Let's put it like that. So we have a lot of refoster collections, rule collections, and we are going to add it to the string rules, string rule collection. And we are at the bottom of the file where I wrote out a comment about what we can do. Is this readable in the back? Good. So yeah, we have to do two things for the refoster rule, the before template, the after template, and then we need to, of course, make sure that the refoster rule actually does what it's supposed to do by writing a test. Okay, so we do a static final clause, new string, and we're going to write the before template. Before, we need to have this array. And here we can actually define what we want to match. So we say, hey, string.copyValueOf with that as parameter. Yes. So this is actually the before template. Now simply the after template. Again, this has to match the before template. And then we say, instead of copyValueOf, we want a new string. And voila, that's it. Fairly easy, right? Okay, now the test. So how this is set up is that for every refoster rule, for every, so this is the string rules file, and we have a string rules input and output file. So we're going to navigate to that. String. So the input file, and I already added the test input here. So this is the way of linking it. So we have the new string is the name of the refoster rule, and here we have to define something that would match, that the refoster rule would match in the before template. And then the idea is that it applies the refoster rule, and then in the output file we define the expected outcome. So let's say we copy this over as input file to the output file at the bottom. Let's check what it does now. I didn't update the content, so it should fill right now. And indeed, what we see is that it doesn't see this in the output file, which is what we specified, but it's correctly matched, so it says, hey, I saw new string. So we update this. If we run it again, we see that it's green, and we now verified that the refoster rule is actually doing what it's supposed to do. Fairly simple. So I want to give a small conclusion about introducing error-prone in your code base. There is the perspective from the developers, which are in general really happy because a lot of their code gets automatically rewritten. And what they also really like is that they can really be part of the process and come with their own ideas to error-prone support. And that they can see the impact on all Picnic's Java code, for example. If they contribute their own rule, it will, within a month, it will be applied on all Picnic's Java code. And it's open source, of course. And the other perspective is for the platform team or the people that maintain the configuration of error-prone. You need to make sure that you tread lightly with respect to enabling new checks. Because if you just enable a check, you roll that out, and there are developers that are like, yeah, I don't like this change, I'm not going to upgrade, and I will just disable it, or yeah, there will be a lot of pushback. So make sure to validate with other teams if they are actually on board, or like whether they like the changes that you want to introduce. It's really important. So if you like what we're doing, or you want to read more, you can go to our engineering blog or to join.picnic.app. Yeah, and here are some links to the documentation website, to the GitHub demo, and on the top right there's a QR code for error-prone support GitHub repository. And I want to give a special thanks to Stefan Schroevers, who is my colleague. He is one of the founding engineers of Picnic and is really responsible for this error-prone mindset within Picnic, and also created error-prone support. So yeah, with that, I actually want to thank you all for your attention. So, are there any questions? Yes. Oh wait, the microphone is coming, of course.
Hello. So my question was, what happens if we have overlapping rules configured? Is there an order followed by?
Yeah, good question. So within error-prone support, we have a self-check that runs error-prone support on itself. So if you write a new rule and you start changing another refoster rule, then there's a problem because you have indeed a cycle. So then, yeah, because of this self-check, we cannot merge anything that is rewriting itself.
Okay.
Good question.
Thanks.
Up there.
Hi, yes. So how complicated can you go with these custom rules? Like how complex can they get?
How with
complex?
the error-prone checks, you mean?
Yes.
Well, you're doing AST transformation, so the abstract syntax tree. You can just make changes to the tree. And yeah, you can go quite far with that. Yeah, there's not really a limitation, I would say.
Okay, thank you.
Don't know if whether you have an example in mind or not, or. No more questions? Okay, well, thanks again. Oh, I have the stickers here, so if you want a version of Cody, then come to the front.